Hello and once again welcome to the second video on triangles class 10th. In first video we discussed about the foundations and the sneak peek of the chapter. We did first exercise at 6.1 and also we discussed and proved basic proportionality theorem. So in this exercise 6.2, this is the first part though, we'll solve some questions based on basic proportionality theorem. So let's begin. Our first question is, we are given two figures, two triangles rather, and DE parallel to BC in both the triangles. We have to find out whether EC in first case and AD in second case. So we'll apply BPT to both and find this EC and AD. Let's see how. So first triangle ABC. Now see, we'll apply basic proportionality theorem. We are given that DE is parallel to, in ABC, DE is parallel to BC. This is given to us, and we know by BPT, basic proportionality theorem, when a line is drawn parallel to one side of the triangle, it divides the other two sides in same ratio. Means AD upon DB is equal to AE upon EC. EC is missing here, so we'll transpose or rearrange this to find the EC. First of all, let's fill the value of the known segments, that is 1.5 AD, DB is 3, AE is 1, and EC we have to find out, right? Rearranging or shifting EC to other side and these segments, these numbers to this side, what we get? We get EC is equal to 1 into 3 upon 1.5. How? 3 is transposed to this side, it will be multiplied in numerator, and 1.5 will be in denominator. Simplifying it, we get 3 upon 1.5 or 30 upon 15, and finally we get EC is equal to 2 centimeter. Clear? Second part is, here AD is missing. We have to find AD. Right? In ABC, DE is parallel to BC is given to us. So by BPT, AD upon DB is equal to AE upon EC. Filling the known segments, we get AD upon 7 upon 2 is equal to 1 upon 1.8 upon 5.4. Or AD, simply transpose 7.2 to this side, it will be multiplied in numerator, and finally we get AD is equal to 12.96 upon 5.4. Further simplifying it, simply we are omitting this decimal from numerator as well as denominator, and finally we get AD is equal to 2.4 centimeter. So this is the way how BPT is applied when a segment is missing from two sides, when a line is drawn parallel to one side of the triangle. Okay, second question. Here we have to check whether the line segment joining the 2 points on the two sides of a triangle is parallel to the third side or not. So again we'll apply this BPT, basic proportionality theorem. Line will only be parallel to the third side if it divides the two sides in same ratio. Right? For each of the following cases, state whether EF is parallel to QR. So we are given a triangle PQR, right, with E on PQ and F on PR. We're given the value of PE, EQ, PF, FR in first case. So let's see the ratio. We'll check the ratio only. PE upon EQ comes out to 1.3. PF upon FR, it comes out to be 1.5. So ratio is not same. Means this EF will not be parallel to QR. Second case, Again, we'll check the ratio PE upon EQ, PF upon FR. It comes out to 8 upon 9 in both the cases, means the ratio is same. So EF is dividing these two sides of triangle in the same ratio. It means that by converse of VPT, it will be parallel to the third side QR. EF is parallel to QR. Okay. In third case, see here we are given PQ, holds this PQ, and similarly PR, not PEQ, this way, whole side. So before actually checking the ratio, we'll perform a little math magic to this. First, now see, consider this ratio PE upon EQ, PF upon FR. Okay, so consider this is an equation. So what we do, we reciprocate the ratio and add 1 to both sides. Reciprocate the ratios and add 1. Now see, we are doing same thing to the both sides of the equation, means our equality will be maintained. Now see what happens by doing so. So PE is the LCM, and by simplifying we get PEQ plus PE upon PEP, in this side FR plus PF upon PF, and see EQ plus PE, EQ plus PE is PQ. Similarly, FR plus PF is PR. So PQ upon PE and PR upon PF, means we started from this ratio and finally raised here. So this is also valid for the line to be parallel, or for the this ratios to be equal. So let's see now if PQ upon PE is equal to PR upon PF or not. So when we simplified this PQ upon PE and PR upon FR, we get 64 upon 9 in both the cases, means the ratio is same. So this EF is equal to EF is parallel to QR. Okay, now see, this thing we'll use in many other questions in coming exercises, this thing, right? How to reciprocate the ratio and this whole side upon this whole side upon this. Okay, sometime we have to do the reverse, means this upon this whole side. So better to understand it in the beginning, that whether PE upon EQ is equal to PF upon FR, or PQ upon PE is equal to PR upon PF, same thing. Okay, this is the same thing. Okay, let's move to third question rather. So we have a figure here. Let's see what sort of figure is this. Okay, in this figure, LM is parallel to CB and LN is parallel to CD, right? This is parallel to this, LM is parallel to this. We have to prove that AM upon AB. Now see, same thing, AM upon AB, AN upon AD. Now see, in this triangle ABC, since LM is parallel to CB, so by VPT, this AM upon MB is equal to AL upon LC. Similarly, in this triangle, LN is parallel to CD, so by VPT, AN upon ND is equal to AL upon LC. From 1 and 2, see, AL upon LC is equal to AM upon MB as well as AN upon ND. So this is equal to this. AM upon MB is equal to AN upon ND, right? Or reciprocating, simply reciprocate the ratio. we get MB upon AM is equal to ND upon AN. And further add 1 to both sides, we get, on simplifying this, further MB plus AM, MB plus AM is equal to AB, and ND plus AN, ND plus AN is equal to AD. So replace this by AB and AD, we get AB upon AM is equal to AD upon AN. So now see where we have to reach, means what we have to prove. Always keep that in mind. We have to prove that AM upon AB, we are getting AB upon AM. So simply reciprocate again the ratio, we get AM upon AB is equal to AN upon AD. Okay, so hence this is proved. Next question. Again we have a figure like this. In this figure we are given that DE is parallel to AC and DF is parallel to AE. We have to prove that BF upon FE is equal to BE upon EC. This is very simple actually. So in first triangle ABC, this whole triangle, DE is parallel to AC, this given. So by BPT we can write BD upon DA is equal to BE upon EC. BD upon DA is equal to BE upon EC. This is equation 1. Similarly in this triangle, sorry, ABE, this one triangle, this DF is parallel to AE, right? DF is parallel to this one, so this will divide the two sides in same ratio. That means BD upon DA is equal to BF upon FE. This is equation 2. So from 1 and 2 equations we see that BF upon FE, sorry, BD upon DA is equal to BE upon EC as well as BF upon FE, which means this BE upon EC is equal to BF upon FE. So this is what we need to prove. BF upon FE is equal to BE upon EC, right? 2 equals equal to same thing, means they both are equal. Let's move for the next question. That is, again we have a figure like this. In this, DE is parallel to OQ, DF is parallel to OR. We have to show that EF is parallel to QR. So EF is, if we consider PQR triangle, EF will only be parallel to QR if this ratio, this upon this, is equal to this upon this. If this EF divides PQ and PR in same ratio, then only EF will be parallel to QR. So let's see how. In this triangle POQ, this DE is parallel to OQ. This is given to us. So by BPT we can write PE upon EQ. PE upon EQ is equal to PD upon DO. Let this be equation number 1. Similarly in this triangle POR, DF is given parallel to QR, right? Then PF upon FR is equal to PD upon DO by BPT. So let this be equation number 2. So from first and second equation, what we get? We get that this PD upon DO is equal to PE upon EQ as well as PF upon FR, right? Both these things are equal to same thing, so means these two will also be equal to one another. Means we get PE upon EQ is equal to PF upon FR. PE upon EQ is equal to PF upon FR. So in this triangle PQR, EF is equal to QR, since it is dividing PQ and PR in same ratio. So we can write by the converse of VPT that EF is parallel to QR, right? So this is the first part of this second exercise. We'll carry on doing other questions in next videos. Until then, keep enjoying your days and keep motivating yourself, because you can do anything, right? Just get up and do it. Follow your dreams. And thanks for watching once again. Thank you.